Hi everybody, welcome to another video in Differential Equations, section 4.4 and section 4.5. In this section, we'll take a look at the non-homogeneous equation. So non-homogeneous equation is when we have the equation where the right-hand side is not equal to 0. The function f of x is called the input function. When it's not equal to 0, this is not a homogeneous equation. Right. So the general solution for the non-homogeneous equation, we have two parts. The first one is the complementary solution, y sub c, and any particular solution, y sub p, and I should say any particular solution will work, and we combine them and solution. So this is the solution of that solution, of that equation. So first of all, it has two parts. Complementary solution come from the homogeneous equation. If that equal to 0, then we will get a complementary solution. Of course, this is the linear second order constant coefficient differential equation, so we know how to do this on the previous section. That gives us the complementary solution, and now we focus on the particular solution to the non-homogeneous equation. Alright, so and the outline here is on 4.4 we use the method of undetermined coefficient. In this case, we're just pretty much guessing to find a particular solution. And then 4.5 is the extension to 4.4. It just allows us to do a lot more with the guessing that we have earlier. In 4.6, complete a different method. It's called the method of variation of parameters, and this is in 4.6, and later on there will be one more method. So to deal with the non-homogeneous equation, there will be three methods. In this section, we focus on the first one. It's called the guessing method, or undetermined coefficients. Right, undetermined coefficient. We will look at a couple of samples before we actually go to how do we guess a solution. Right. Example 1. Find a particular solution y double prime plus 3y prime plus 2y equal to 3t, given that a particular solution is of the form at plus b. So in this example, we are given the form of the particular solution. Later on, we have to come up with the form by guessing, but for now, assume that it is given. Now, if it is given a solution like that, we take derivative. So we have the function, take derivative, and then second derivative. Substitute in here. Second derivative is 0. First derivative is a, and the function at plus b. All of the left-hand side must be equal to 3t on the right-hand side, and multiply it out. And then we matching the coefficient. On the left-hand side, we have 2at. On the right-hand side, we have 3t. So the two polynomials or two expressions are equal. If the variables are equal, then the coefficient must be equal. So that method is called the undetermined coefficient. So we have 3t equal to 2at, t and t cancel. We have 2a equal to 3. So that's the first part. The second part, this is a constant, and on the other side we do not have any constant. So we will make that equal to 0. And solve this system of equation. We have a equal to 3.5, b is negative 9 over 4, and we'll put this back into the particular solution, and that's what we have. Now let's try another one. Find a particular solution to this non-homogeneous equation if that is particular solution it is in this form. So because we know the particular solution in that form, then we just go from there, right? So the function or solution a cosine of t plus b sine t. Alright, we'll check derivative. Derivative of this is negative a sine t. Derivative of b sine t is b cosine t. Alright, so that's the derivative. Now we take the second derivative. Will be negative a derivative of sine cosine. Derivative of b, derivative of cosine is negative sine, so that's what we have. That. Right, so the function derivative, second derivative, and now we substitute into the original equation. Continue on the next page. So we substitute that. The original equation. I'm just going to copy that. Right. Second derivative is going to be negative a cosine minus b sine t. That's the second derivative. Plus 3 times derivative and then plus 2 times the function. Equal to sine t. Right, to substitute second derivative, first derivative, the function. Right, now the next just combine like terms. The way we do the combine like terms, a systematic way. Of course, we can multiply them out and then combine like terms, but we'll just do this. Notice that when we look at the terms, there's only only cosine and sine. So let's group all the cosine together. So underline the cosine. So factor out cosine. What's left? What will be the coefficient? First of all, it is negative 8. Right? And then there's a b with cosine of t. But because the b multiplied with 3 as well. So 3b. And then plus 2a. Of course, we can multiply them out and combine like terms. It's fine, but we can. It'll be quicker if we just combine like terms like this. Right, plus. Now let's look at the sine t. For sine t, we have negative b plus 3 plus 3 times negative a. Then plus 2 times b. Right? And that's equal to sine t. Right? Now, matching the coefficient on both sides. The sine t here has to be equal to this sine t here. Oh, by the way, let's just simplify this first. Cosine of t, that minus a plus 2a, so it's minus a. 2a minus a, so positive a, plus 3b plus sine of t, negative 3a plus b. Right? And that equal to sine t. Right, so now we will just match the coefficient. Sine t, we match with sine t. The coefficient for sine t is 1, therefore negative 3a plus b has to be equal to 1. And then there's no cosine. And we match that with cosine here. So in that case, a plus 3b has to be equal to 0 because there's no cosine. Right? And we solve for this. And to solve this equation, I've used the calculator. The fastest way is to enter this in the matrix and then apply the row reduced echelon form. So enter the matrix, second matrix. We write this as the system negative 3, 1, and 1, 1, 3, and 0. So enter this in the matrix and we will do reduce row echelon form. So second matrix, go to edit, hit enter, and now we enter the matrix 2 by 3, 2 times 3. Right, negative 3, enter, 1, 1, 1, 3, and 0. So pretty much we enter the coefficient and the constant on the other side. Right, and then second mode, back to home screen, and go back to second matrix. We have the matrix there already. Now we go to math, go to option B. Again, second matrix, go to math, option B, and we apply to matrix A. So second matrix, under names, highlight A, hit enter, and we convert this to fraction. So negative 3 over 10 and 1 over 10. So since in this form we write A and then B, so the first one is A, the second one is B. So we have the equation. Particular solution was a cosine t plus b sine t. So a is negative 3 over 10 cosine t, and b is 1 over 10 sine t. Right. So it will be just like that. Right. Yeah, try to be organized. And I usually use the calculator. So that is one way to do that. Another way, if you calculate TI-84 and with the new operating system, you can just do directly on the home screen. So second matrix, go to math, and once again go to option B. Then hit alpha, zoom, and go to 2/3 and OK. Right. It's important that when you enter the numbers in this form, do not hit the enter key until we done. So negative 3, don't hit enter, but hit next. 1, next. 1, 1, 3, 0. Close parentheses and hit enter. Of course, we can change to fraction. Right, so don't worry about this. We will do a lot more sample of this. But the most important is, where do we start? How do we get to the form here? Right? So that is what we have. So the form for the particular solution, or the one that we get here, of course depends on the input function, the one on the right, and also have to depends on what on the left as well. So we cannot just look at the function on the right and guess the function. We have to know what happened on the left hand side as well. Right. So here the guidelines of how do we guess a solution. Right. There will be 3 parts. The first part corresponding to polynomial of degree n. The second part will have exponential function and then there's some power terms multiplied to it, or a polynomial multiplied to it. Or I can say it, by the way, polynomial of degree n we can write as Pn of t. Here, instead of this form, we can also write as polynomial of degree m of t times e to the rt. Yeah, so either that or in that form. So we have a polynomial times exponential terms. And the next one is either we have cosine or cosine. Sine or cosine. Of course, that is corresponding to the form of the complementary solution. Right, so either cosine or sine. All right, now the guess. Now, if it is a polynomial, we will guess a polynomial of the same degree. So if it is the same polynomial, we will guess the same degree here. But then, of course, what is the deal of t to the s power here? So t to the s here will be there if, remember on the previous section when we said if we have the solution, if r is equal to the double root of 1, then the solution is e to the t, and then y2 is e to the t. We cannot do that because those two are not linearly independent. So we have to put the t to it to make it different. to make it linearly independent. So that's why we multiply a t to it. Likewise, we multiply the t to it if there is some redundancy for the independent to make them linearly independent. So for linearly independent, and all of them have it. So all of them will have a term like this. And then next, if it is in this form of a polynomial times exponential, we will get the same thing, the full polynomial times exponential. And then multiply t here, power of t, to make it linearly independent. So if there is any redundant with the complementary solution, then we have to multiply extra t to it. That's not much there. However, when we have either sine or cosine, or maybe both, the guess is always both of them. So even though there's only cosine, we always have to guess both sine or cosine. So now go back to our problem. When here's a sine, we have to guess both of sine and cosine, because the answer might have both of them. Right, so that's the idea. And once again, we multiply t here for independent, linearly independent purpose, to make them linearly independent. Right. Then of course, don't mind about this root and then kind of worry about that later. Like I said, the point here is to make them linearly independent. Right, now, so, yeah, you should have this page when you taking homework. You don't need to write s 0x equal to 0, x equal to 1, s equal to 2, or whatever it is. Just write the 3 lines, and knowing that t of s multiplied the power of t for linearly independent. Right. Right. I'll find the form of particular solution given the input function as well. So we have a bunch of examples here. Now first, of course, even though it depends on the right hand side, definitely yes, the guess depends on the right hand side, but we have to solve for the left hand side to see if there is anything redundant. If it is redundant, multiply by t to make it linearly independent. Right. So first we have to look at the left hand side and solve for the complementary solution. So first, of course, to do that we will solve for the auxiliary equation. And for that, second, of course, there's a typo here. Obviously, this should be first derivative. R squared plus 2r minus 3 equal to 0. Yeah. So first we just look at the homogeneous equation, or for the auxiliary equation. So we assume that the function just equal to 0, right? So assume that the right hand side is equal to 0. Homogeneous equation, then we can write the corresponding. I just do that first. First, of course, the homogeneous equation. It's just that equation, but equal to 0. And for that homogeneous equation, we have auxiliary equation corresponding to that. Now factor, we have r plus 3 and r minus 1. Because when we multiply my house square plus 3r, yeah, that's correct. So we have r equal to -3 and r equal to -1. I mean positive 1. So let's say R1 and R2. So we can say the first solution is e to the negative 3t, right? And y2 e to the t. Right? So that's the first thing we do. Look for the complementary solution. Because when we do that, we can say complementary solution is the linear combination of these two. C1 e to negative 3t plus C2 e to the t. So the complementary solution is the solution to the homogeneous equation. So first thing we write the auxiliary equation for homogeneous equation. And that's what we have. Right. Now we look at each particular problem. Right. First, we look at this. The input function now f of t is equal to 7 cosine 3t. So if we have the equation, because the left hand side is that, now what we're looking at is the problem of now the equation is in this form. The right hand side is given equal to those functions. Now, if this is the solution, the guess will be I said have this page handy. If we have either sine or cosine, the guess will be have to be both sine and cosine. So it's going to be sine and cosine of the same term. And the degree of that is 7. So it's going to be the same degree, which is constant. So our guess is going to be A cosine of 3t plus B sine of 3t. It's going to be the same as that. Right? And now we looked the solution here compared to that and that. So those are linearly independent to e to negative 3t and e to the t. So in that case, we don't do anything. That's it. That is our guess. So those are linearly independent to y1 and y2. Let's write a little note. So this is linearly independent to y1 and y2. Right, next. Next, another guess. If the right hand side is this, so this have two components. The first component is the et sine t. So every time we have that, we're going to have sine and cosine and e to the t. So the guess must have those terms. When we have that, it's going to be e to the t. But notice we also have a polynomial in front of that. Also have the 2t. And so this is polynomial of degree 1. Or it could just say binomial. But this is degree 1, so we're going to have a polynomial of degree 1 times the e to the t sine t. When there's sine or cosine, there will be both. And there's also another polynomial degree 1 times e to the t cosine t. And once again, we look at e to the t sine t and e to the t cosine t is linearly independent from here. The solution is e to the t or e to negative 3t, even though we have e to the t, but it's not this one, we have sine cosine as well. So e to the t sine t, e to the t cosine t are linearly independent for those two, so we don't need to do anything else. Right. Next, if the right hand side is equal to this, our guess will be when there's sine, there will be cosine. This will just have cosine. There's no e to the t, so we don't worry about that. So we just have cosine of pi t. Just need more space. And here we have t squared, which is the second degree. Polynomial. So I have a second degree polynomial multiplied to it. So in the guess solution, we will have to have a second degree polynomial. By the way, in the book, they may have C1, C2, C3, or I write like this. Don't want to use D though. So let's say A1 T square. No, usually don't write like that. A2 T square, A1 T A0. So this is also a second degree polynomial. And then we will have cosine of pi t. And then another second degree polynomial, b2t squared, b1t, b0. And now we will have sine of pi t. Where we have either sine or cosine, the guess have to have both. And it depends on if we have a polynomial multiplied to it, we have to have the full polynomial multiplied to it. That is the guess. Of course, some of them may be 0, but the guess have to have everything. Right. Now things will get more interesting. Now, let's guess. 5e to negative 3t. So the guess would be... By the way, the reason we don't have anything here because 7 is a constant. So we just need to have a constant in front of it. So here the guess. It's a constant. So it's just going to be a constant. Simple enough. Right. Now, if we look at e to negative 3t and that e to negative 3t, so it cannot be that. It has to be linearly independent to this. So our guess had to be something different. So we multiply a power of t here, just to make it different. So this is for linearly independent. To y1 and y2. Of course, y1 and y2. Now, because the way we write the solution, y equal to complementary solution plus particular solution, if we write out complementary solution is here. C1 e to negative 3t plus C2 e to the t. And then our guess, if our guess solution is a e to negative 3t, if we're going to guess that, of course, there's the redundant between these two, right? So to make it not redundant, precisely make that linearly independent, we will multiply t here. So that term is different than that term. Right, so that's what affecting our guess. The complementary solution certainly affect our guess. So in that case, that's just what we have, or we just write a t e to negative 3t. Right. Next, let's guess in this form. It has e to the t. It has e to the t here. And then we have a first degree polynomial. First degree polynomial. So our guess will be a first degree polynomial. At plus b or a1t plus a naught. Because in the book or in the answer you might want to write a1t plus a naught. Still the same thing though. And then e to the t. If this is e to the t. Right. However, when we look at this e to the t, we already have that as the solution for complementary solution. So it have to be something else. So make it something else, put the t here for linearly independent. Because the e to the t is there already. So if it is linearly independent already, we don't need to multiply by t or any power of t. But if it is linearly independent, we have to multiply by t. Right. Let's try another one. For this problem, once again we have e to the t, but we also have the second degree polynomial. I just write second degree. So we have to guess second degree because we need to write the second degree. So I'm just going to write this. And then e to the t. Because e to the t is the form. So, and then once again e to the t is there already. So we have to multiply by an extra t for linearly independent. I'm not going to write that again, but now we know why we have to multiply by t. Right, so it will be just that. Of course, or we can multiply them out if we want to. Sorry, I wrote at the wrong place, so multiply t here. Sorry about that. Even though with all the color code, I'm still confused. Of course, when it's like that, we can multiply them out if we want to, like at squared plus bt. Same thing here, multiply them out. At cubed plus bt squared plus ct e to the t. And finally, for this one, we'll just guess. This is just a second degree, so our guess is the second degree polynomial. And all of these terms are different than that, so we don't need to do anything. That is our guess. Right. So if it is a polynomial, our guess is also the same degree polynomial. If it is e to the t times a polynomial, it's still the full polynomial times e to the t. And we will multiply by t or t squared, t cubed, or whatever it is, just to make them linearly independent. And when we have either sine or cosine, the guess have to be both of them. Or e to the t sine t, or e to anything. E to alpha t cosine beta t, or sine of beta t, our guess will be the same thing. Have both sine, cosine. Right. So those are the examples. Once we do that, check derivative, substitute into the equation, and so forth. The math is not that difficult, but it could be very tedious. Right. Now, more example. Oh, this is exactly like what we have here. So example 4. Find the form of the particular solution. Now this we only find the form, we not actually find the solution. So still need to find the solution to auxiliary equation. We have that, and so we have e to negative t and e to negative 2t. And then here we guess. So this is the solution if we use the book. A little more difficult. We're going to guess the first. So this has the form of e to the negative 2t. So we're going to guess the same thing. First degree polynomial, our guess is going to be at plus b, the full first degree polynomial. And we have potentially multiplied by t to the s if s is any solution. And for this one, the solution, I mean, this should be r, not m. The solution is r equal to negative 2. Multiplicity of 1. So that's why we'll have that to the first power multiplicity. So if that have the same degree as this. But like I said, that is usually not a very intuitive way to solve the problem. You should do like what I did earlier, which is either one of those steps. We have to multiply something to make the solution linearly independent with the complementary solution. That factor is good enough. So either those two solutions will express the same thing. We want it to be linearly independent. Like if this is the complementary solution, and if this is particular solution, if there is anything that make it, if there's anything that make it not linearly independent, like those two terms are the same, we have to multiply everything by t to the guess solution. So that's why we have to multiply by a t here for linearly independent purpose. Right? Yeah. So that's exactly what that is how I would approach the problem. Right. Now let's look at more example. Find the form of particular solution to this problem. So of course we have to solve for auxiliary equation. First, get the y1, y2, see if there's any repeat solution. In that case, multiply by t to make it linearly independent. So first, homogeneous equation or particular, complementary solution. So for auxiliary equation, second, first problem, let's write full details. Auxiliary equation for homogeneous equation. So we're just going to make this equal to 0. And the auxiliary equation for that is r squared minus 5r plus 4 equal to 0. So in that case we have r minus 4 and r minus 1, right, equal to 0. So if R1 equal to 4 and R2 equal to 1. So for that we have y1 is e to the 4t, y2 e to the t, and complementary solution c1 e to the 4t plus c2 e to the t. Right, so that's the first step we do. The next step is, according to this, we will guess that's a cosine times constant. So we will have cosine and sine. And those solutions, cosine 3t, sine 3t, are linearly independent to those two. So don't need to multiply by t or anything. Right, the next one is a little more interesting. Right, so first we'll write the auxiliary equation. I'm not going to spell the whole thing like this. It says auxiliary equation. Of course, auxiliary equation only for the homogeneous equation. And we only get the complementary solution. Right. That will be r squared minus 2r plus 1 equal to 0. So this we factor r minus 1, and then so we have r equal to 1, and this is a double root or multiplicity of 2. So in that case, the solution, we will have y1 equal to e to the t, and y2 also the same thing, but that would be the same thing. So for linearly independent purpose, we have to multiply by t to it. And with that we have complementary solution c1 y1 plus c2 y2. So c1 e to the t plus c2 e to the t e to the t. Right. So that is for auxiliary equation for the complementary solution. Complementary solution, that's what we have. Now for particular solution, we're going to guess our guess is this has e to the t times a polynomial of second degree. So our guess will be a second degree polynomial. Times e to the t. Now, that one redundant with this. So if it's redundant, multiply by t to it. Now, but when we multiply, we have the constant times t times that, still redundant. So in this case, we actually have to multiply by t squared. Because when we multiply t squared, let's just multiply this out. We have a2 t to the 4th e to the t a1 t cubed e to the t and a naught t squared e to the t. You see, when we multiply them out, this should be linearly independent to that, and it is the case, right? It's the smallest t squared, which is different than that. If we don't multiply by t squared, there will be some redundant. They would not be linearly independent, so that's why we have to multiply by t squared there. Right, so right. Next for this one. First, of course, we find the complementary solution. Right, will be r squared minus 2r plus 2 equal to 0. Right, and doesn't look like it can be factored because multiplied by 2, it could be 1 times 2, but they won't combine to negative 2. So the quadratic formula minus b plus or minus b squared minus 4ac over 2a minus negative 2 plus or minus square root of negative 2 squared minus 4ac over 2a. So that gives us 2 plus or minus 2 squared is 4 minus 8, so minus 4. And that is over 2. So 2 plus or minus, since we have a negative inside square root, that is imaginary, and square 4 is 2. Factor out 2 from the top. Have to factor it first, because only when we factor we can simplify with the bottom. It has to be a product where we can simplify. So I have 1 plus or minus I. Right, now this is a complex solution, right? So we say R1, 2 is 1 plus or minus I, which if we write in the complex form, complex form of alpha plus or minus beta I. So in this case, alpha is 1 and beta is 1. So the y1 is going to be e to the alpha t cosine beta t, so or e to the t cosine t, because alpha and beta equal to 1. y2 e to the alpha t sine of beta t, so e to the t sine t, both alpha and beta equal to 1. Of course, a linear combination, so we can get complementary solution. Be this one. sorry, we only have this much space for the guess solution. Right, so yp, if we have to guess, in that form we will have e to the t cosine t, so it's going to be that time sine and cosine. Of course, also polynomial of the first degree, so it's going to be a1t plus a naught, and then e to the t cosine, and then b 1t plus b naught, and then e to the t sine t. Now, when we look at this, there's excuse me, there's some redundant. E to t cosine t and e to the t sine t, that's redundant. So if it's redundant, we multiply by t, because when we do that, it's going to be a1t squared, which is good, and a naught times t, so there will be a t. So we'll make this one different than that, make this one linearly independent to that, the same thing for the other one. So we multiply by t, or sometime, like the last example, we have to multiply by t squared to make it linearly independent. And a particular solution should be linearly independent to the complementary solution. I say should be, because the guess in that form will be easier to do. Of course, if we don't want to, we can guess the solution. Okay, I will do that in the next few examples. Right, so find the general solution to this one. So the general solution will compose of two parts: complementary solution and particular solution. So let's do the first step, complementary solution. Right, so of course we write the auxiliary equation. So we don't need to write the right hand side now. R square minus 2r, and there's no function, so there's no r, no constant here, and no function, so there's no constant, and that's all we have. Right, so factor it out. So we have r1 is equal to 0 and r2 is equal to 2. So y1 equal to e to the 0t, or anything raised to 0 power is 1. y2 e to the 2t, and complementary solution, linear combination of them, c1 times 1 plus c2 e to the 2t. So y complementary solution is c1 plus c2 e to the 2t. So that's what we have, complementary solution. Now go to particular solution. Right, let's guess. Right, so what we have here is a second degree polynomial, so trinomial. So I guess in general we have at squared plus bt plus c. So they have to be full second degree polynomial. Right, now is that linearly independent to the complementary solution? And the answer is no, because we have a constant and we have a constant. Both of those are constant, so are not linearly independent. So to make them different, multiply by t. To make them linearly independent, I need to multiply by a t there. So in that case, it would not be the same. So let's multiply it out. At cubed, bt squared, and ct. As you see, all of them are linearly independent to that, which is good. It has to be that. Because if we can also write, it might be a constant here, but later on we can just combine those two together. So even though we can write a constant here too if we want to, but it's not going to affect anything. Right, so that is the guess. In that case, we can go to the derivative. 3at squared plus 2bt plus c, and then we can go to the second derivative. 6at plus 2b right. Now we substitute all of this into the equation. The equation is this. Right, so first, second derivative is this. So I will have 6at plus 2b for second derivative. Minus 2 times the first derivative, which is this. And that has to be equal to 3t squared. Right. Now combine like terms, or multiply them out and combine like terms. Of course, you can multiply them out, or we just do combine like terms that the way I did earlier. For this one, let's just multiply them out. But that's simple enough. 6at 2b 6at squared minus 4bt minus 2c. Right, combine like terms. How many t squared do we have? Just one, right? How many t do we have? One here, and there 2. Factor out the t. And what do we have in the parentheses? Factor out the t will be 6a minus 4b, and then constant 2b and minus 2c. And that equal to 3t squared. Right, now we're just matching the t square here, coefficient must be the same. So negative 6a is equal to 3. That's the first part. Second, this term has no t on the other side, so we have 6a minus 3b is equal to 0. And finally, that there's nothing on the other side. So actually this one we don't need to put in the calculator because this is simple enough just to do that by hand. So a is what? 3 divided by negative 6, negative 1/2. This equation, if we solve for b, 3b equal to 6a. So b is equal to 2a. Sorry. Okay, so b equal to 2a. Sorry, I have to pause the video and check something real quick. I just copied it wrong. Even with all the color coding, I still missed it. This is minus 4b. The point of color coding is to help us to keep track of things. It didn't work very well there. Right, so 6 divided by 2 should be 3/2. So 3/2 times negative 1/2. That's negative 3/4. And finally, 2b equal to 2c. So b equal to c equal to negative 3/4 because b and c are equal. So we have a, b, and c. Of course, we substitute back into the guess solution. So y particular a is negative 1/2 t cubed minus 3/4 t squared minus 3/4 t. And that is a particular solution. So here we have complementary solution, and here we have particular solution. So when we have general solution, will be complementary solution plus particular solution. So that will be C1 plus C2 e to the 2t plus that. This section is not difficult, but it is very tedious. So because that is going to be very long. Right, next we have superposition principles, which is section 4.5. Also, to make the problem long, I combine the two sections together. That's why it's also right, superposition principle. So the theorem says if we have the homogeneous equation, both of them are the same. Notice that this part of the equation are identical. So the left hand side are identical. And if we have two different solutions, if we have y1 and y2 are particular solution to that, then the particular solution will have the same linearly combination as the combination on the right hand side. So notice that the combination of k1 f1 k2 f2 is the same thing as k1 y1 k2 y2, right? So the same linearly combination on the right hand side give us the particular solution is the same linear combination of each of the particular solution. Right. An example to this is find the form for the particular solution of this one. So in this we have two forms. First, of course, we always have to solve for the left hand side, and we have y1 e to the 2t, y2 e to the negative 2t. So the first part of e to the 2t, if we have to guess for that part, it's going to be e to the 2t the same. There's the t, so we have a polynomial of the same degree, of matching degree polynomial. But because of e to the 2t here are redundant with that, so I will multiply by t here for linearly independent. So if I have to guess the solution for that term, it's going to be this. Next, I'm going to guess the solution for this term. Of course, that will be cosine and sine. And I don't need to multiply by t because those solutions are linearly independent to those two. And there's a 5, so just constant. If you notice, I avoid to use d as a constant because later on d is said to be a derivative. So that's different operator, so we don't want to use d. So the superposition principle says if on the right hand side we have the sum of those two functions, then we're going to have the sum of these two guess solution. Right. Right, now let's look at an example. As mentioned before, this section is very long, so we have a long way to go here. So, find particular solution to this. Even though the guess solution has two terms, but can we combine them? Both of them have e to the t, right? So even though it look like this, we still can combine them if we want to. E to t plus 2 e to the t. So in that case, it's not much. So not actually superposition principle here. There's no thing. There's only one term here. Right. So let's do this. First one, complementary solution. Even though the question only asks us for particular solution, we still need to find a particular solution. Well, so first step is complementary solution. So auxiliary equation for that. R square, that y, so it's r square minus 1. So factor r minus 1, r plus 1 equal to 0. So if r1 is equal to 1, r2 is equal to negative 1. And with that we have y1 is equal to e to the t, y2 e to the negative t. And of course the question did not ask, but the complementary solution will be c1 e to the t plus c2 e to negative t. now we go to 2. Particular solution. A particular solution, we're gonna guess. Because later on in section 4.6 there's another way to do this, and in chapter 6 there's another way to do this, but like I said, none of the methods are simple, usually very long, not that difficult, but extremely tedious. So we're going to guess. Particular solution will take the form of, oh, this is the one that we guess. So it has e to the t, right? So suddenly it will have e to the t. A first degree polynomial. So this is the first degree polynomial. So we're going to guess to have at plus b. And by the way, is there any redundant with this? And unfortunately there is. If we multiply them out, it will be a constant times e to the t, which is the same thing as e to the t there. So that's redundant. So to make them linearly independent, I need to multiply by t. So multiply everything out. The guess solution will take the form of at squared e to the t plus b t e to the t. Alright, so that is the function. Now let's find the derivative. Derivative, this is going to be a product rule. So product rule, u prime v, derivative of that is 2at e to the t plus at squared. Derivative of e to the t is still e to the t. At least we have that. U prime v plus u v prime. Right, so that is the derivative. It's not that bad. And then second derivative. This is the first derivative. So second derivative, that a product rule, 2a e to the t plus 2at e to the t. Good thing here is e to the t derivative, just e to the t. So that's the first term. Second one is a product rule, 2at e to the t plus at squared e to the t. So that u prime v, u v prime. Next, this one, it's just a constant, so there's no product rule, just be e to the t. And then the next one is still product rule, b e to the t plus bt e to the t. Right, now put all of this together, substitute into that equation. And for many of these problems, the problem might have more than one line. So second derivative, which we can just copy and paste. Right. Oh well. Of course, there's something to combine, but of course we do that later. Right. carefully copy this. Well, of course, I did say that combine like terms later, but this look obvious that those two are the same, as those two terms are the same, but just for now. So there are two of those, and then b t e to the t. So that is the second derivative. Going to minus the function would be that. Equal to the right hand side of this. Right, combine like terms. So how many of these do we have? Right. First, let's look at e to the, we have a t squared e to the t. Let's see how many of those do we have. 1 and 2. Right, so factor out t squared e to the t. Inside, what do we have? There's an a and there's a minus a. Right, so that takes care of t squared e to the t. Of course, that's just 0, which is the same thing on the right hand side. So we're supposed to have 0 here, which what we have, which is good. That's the first thing. Second, what else? T e to the t. How many do we have? Oh, t to the t. So there's 2a here. There's another 2a. Make it 4a. There's a b. And there's minus b. I'll take care of the t e to the t. Now, next one I will use orange. E to the t, e to the t, e to the t. I don't have anything here, so that's those all of them. There's 2a and there's 2b. At e to the t plus 2e to the t. Now, good thing is that one cancel out because there's a minus a 0. Now we will match t e to the t. So here we have that also cancel out. So that give us 4/8 equal to 8. Right? The same thing, for a coefficient have to be equal to 8. And then when we match the e to the t with this, we have 2a plus 2b is equal to 2. So that is the system of equation that we have. Once again, we can show by hand. Give us a equal to 2 and substitute 2 in here. That 4 to the other side is negative 2, so 2b is negative 2. So b is equal to negative 1. Now, the particular solution is in this form. This is the guess. So we substitute into that. Substitute into that. So particular solution is a, which is 2 t squared e to the t plus b, which is negative 1. Minus 1 t e to the t. Right, so that is the particular solution to our problem. Alright, next we have this problem. And then we say, how do we supposed to do that? That take a lot of space, right? Why do we only have one line? Well, let's just write what we have from the previous example. Of course, there must be some trick to this. So from the previous example, we have this solution. So 4 y double prime minus y equal to at e to the t plus 2e to the t. For that equation, we have particular solution is that. Right, so that's what we have from the previous part of the problem. Now we have this equation. Now let me ask you this. If we see the left hand side, the homogeneous part of the equation, those are the same, right? What is the relation of this, the right hand side, and this? How do we go from here to there? Right. Now from this into this, what we have to do? Of course, in your note, this should be minus. I forgot to change that in the note. Now, once again, compare those two solutions. What is the difference? Of course, here we have 18 and then we have negative 4. So look like what we do is multiply by negative 1/2, right? So if the right hand side of the, on the left hand side are the same, if the right hand side multiplied by negative 1/2, of course that gives us negative e to the t. In that case, the solution, particular solution, we don't have to do anything, just multiply by negative 1/2. And this is the superposition principle. So as long as the right hand side are the same, the linear combination of the right, as long as the left hand side are the same, if we have the linear combination of the right hand side, we will have the same linear combination for the particular solution. That cancel out. So that is the superposition principle. If there's another function, we write the linear combination of those two. But here we only have one, so that's how it works. Yeah, and I thought I need to do one example that has the superposition principle into it. Right, so that's good. Now let's look at another example here. Find a general solution to that. Right. So first, of course, we need the complementary solution. Auxiliary equation r square plus that is 4 equal to 0. So we solve for r square, that negative 4, so r equal to plus or minus square root of negative 4, which gives us imaginary, because the plus or minus. Times 2, square root of 4 is 2. So r equal to plus or minus 2i. Plus or minus 2i. So if we write it in the complex form, the form of alpha I plus or minus beta I, alpha plus or minus beta I, the complex form like that, then alpha equal to 0, beta equal to 2. So the solution y1 equal to e2 alpha t cosine beta t, alpha 0, so e to the 0 cosine of 2t, or this just cosine of 2t. y2 e alpha t sine of beta t, or just sine of 2t. Right, and the complementary solution, c1 y1 plus c2 y2, c1 cosine of 2t, c2 sine of 2t. Right. That is the complementary solution. Now the second part of us, the particular solution. Right. Guess. particular solution, we guess. Let's look at this form. It has cosine of 2t. Right. Every time there's sine or cosine, we're going to need both. So we're going to have good thing here. Just multiply by a constant. So we don't need anymore. So it's just a constant. Now the bad news is, compared to y1 and y2, they are not linearly independent. So we may have to multiply by t here. Otherwise, it will be the same thing as y1, y2. So I have at cosine 2t, bt sine of 2t. Right, so that is the solution. Now, find derivative, second derivative. Bad news is derivative of this has to be a product rule, and this looks complicated. Right, product rule. Derivative of at is a times cosine of 2t plus the first term with derivative of second. Derivative of cosine 2t is negative 2 sine of 2t and then b sine 2t plus bt, derivative of that is 2 cosine 2t. Right, let's rewrite this, the negative here. A cosine 2t minus 2at sine 2t plus b sine 2t plus 2bt cosine 2t. Alright, now take derivative one more time. Just forgot. That is the derivative. Now second derivative. Right, so that one's easy. Negative 2a sine of 2t. Yeah. Don't forget there's the chain rule. Because of 2t, then we have to take derivative of 2t. So that's why there's a 2. Now for this one, it is the product rule. Negative 2a sine 2t and then minus 2at sine 2t is cosine 2t, 2 cosine 2t. Derivative of this is 2b cosine 2t and then derivative of that 2b cosine 2t plus 2bt negative 2 sine 2t. Right, combine like terms. And we do have some like terms here. Like namely the first two. Negative 4a sine of 2t this gives us negative 4at cosine 2t. These two terms are the same. And then minus 4bt sine of 2t. Right, so that is the second derivative. That is the function derivative. Now we substitute into the original equation. First, the second derivative. Right, so that is the derivative plus 4 times the function at cosine 2t plus bt sine 2t, that equal to the right hand side of a cosine 2t. Right, now try to combine. How many different terms do we have here? And that's quite a few terms. First, there's sine 2t, cosine 2t, t cosine 2t, t sine 2t. So there's like 4 different terms. We need to combine all of them. So first, sine t. That's only one there. This is t, so that's different term. And do we have anything here? Nope. So that's just that term by itself. That's one. Next, cosine 2t. No, we don't have that here, right? These have the t, these have t, so that's the only term we have. Now we have the t cosine t. Need to combine them. T cosine 2t. Inside we have negative 4a. And this gives us 4a. Alright, that cancels out nicely. And then t sine 2t. Factor out the negative 4b, and there's a 4b. So that's all. And that will be equal to 8 cosine 2t on the other side. Right. Good thing here, even though there's 4 terms, but this is 0, and this is 0. And the only thing that equal to here is a cosine 2t and 4b cosine 2t here. So the only thing we can get from the equation, actually 2 things. 4b is equal to 8 because both of them have cosine of 2t. And then we don't have anything on the other side that have sine of 2t. So negative 4a is equal to 0. So that is our system of equation. So b equal to 2 and a is equal to 0, and our particular solution is the form of at cosine 2t, so a is 0, plus 2 times t sine of 2t. So particular solution is equal to 2t sine of 2t. So complementary solution, particular solution, combine the two, we have general solution y equal to complementary solution plus particular solution. Complementary solution is that. And then particular solution. Let me zoom out so we can see the whole problem. Yeah, that's not very clear, but yeah. So that's what we have. So it's not that difficult. It's just a bit tedious, and the more organized you are this step, the better. So that's what we have. Now, I did mention that when we have particular solution, we can use any particular solution will do. So in that case, if you want to, or if we want to, we can let C1 to be 1, C2 to be 2. So a particular solution also can be in this form, like cosine of 2t, and then 2 sine of 2t. This, where I let C1 equal to 1, C2 equal to 2, this also a particular solution. So a particular solution might have a term into that too. There's nothing wrong with that. But in terms of our calculation, we're gonna let C1, C2 to be 0. So we're trying to find this, because if we have a bunch more coefficient, it will be very difficult to solve for. Right. So in that case, we just let the in that case, the particular solution and complementary solution are linearly independent as well. So in that case, it's similar to solve for. Right. Now, we haven't done anything that has initial condition into it, so we at least have to do one problem that have it. So in that case, we can test and see how that works, how the equation works. Right. So still same thing. First, complementary solution. Auxiliary equation. R squared plus 16 equal to 0. So R squared equal to negative 16. So R equal to plus or minus square root of negative 16, which is plus or minus 4i. Right, and similar to the last problem, if this is equal to alpha plus beta I, then alpha is equal to 0 and beta is equal to 4. If it is a complex conjugate solutions, if there are complex conjugate solution, so we will have y1 equal to e2 alpha t cosine beta t so just cosine 4t. y2 e2 alpha t sine of beta t e to 0 sine of 4t e to 0 power is 1. So let's just cosine sine here. So our complementary solution is equal to c1 cosine 4t plus c2 sine of 4t. We don't put in the initial condition yet. We only put in the initial condition when we have the general solution. So this is just a complementary solution. So that's the first part. Next, particular solution. So we will guess in this form e to the 2t. So that's going to be, we'll take the exponential form, and that's just a constant. So the guess in this case will be just a constant times e to the 2t, and this is linearly independent to those two. So it's good, we don't need to do anything. So that's just that. Then we'll take derivative. It's going to be 2a. Don't forget that is the chain rule. Derivative of e to 2t is we take derivative of that. It's going to be a. Derivative of e to the 2t is the same thing, but then we have to take derivative of the 2t, which is 2. So that makes it 2a e to the 2t. And second derivative is going to be 4a e to the 2t. Be careful with that. And now we substitute into the equation. This is not that bad, so I don't need any color code because that's second derivative. Second derivative plus 16 times the first derivative. Times the function. Equal to 40 e to the 2t. Combine like terms 4 and 16, that makes 20. Because this one we only have one coefficient to solve for, so that we only have one equation. Now, both of them have e to the 2t. So in that case, 20a has to be equal to 4. 20a equal to 40, so a is equal to 2. So we have the particular solution. A is 2 e to the 2t. So that particular solution, and this is complementary solution. Combine them, we have a general solution. General solution is complementary solution plus particular solution. And that plus particular solution. Right, so that's good and all. Next, we need to solve for the initial condition. Right, let's go to number 4 for that problem. Initial condition. Yeah. Notice that in this, when we have initial variable problem, we will find the general solution first before we consider the initial conditions. The first one, when t equal to 0, the whole thing equal to 5. So I'm going to put 5 in for y. And 0 for t. Well, let's try to simplify what we have here. Sine of 0 is 0. E of 0 power is 1. Cosine of 0 is 1. So when we combine all of that, we have 5 equal to C1 plus 2. And of course, in this case, we can solve for C1. It must be 3. Right. So that's the first initial condition. Next, our derivative is equal to 1. So in that case, we have to check derivative first. So this is the general solution, derivative. Cosine is negative sine, and then derivative of 4t, so we have negative 4. C1 sine of 4t. Same thing here, derivative of sine is 4 cosine, and then derivative of 4t is 4. So don't forget, there's a chain rule. It's cosine 4t. And also the chain rule here. Now, after that, we put in 0 in for t and make that equal to 1. Negative 4 C1. We know C1 is 3 though. Sine of 4 times 0. That doesn't matter because sine of 0 is 0. 4 times C2. Cosine of 4 times 0 plus 4 E 0 times 2. Same thing. Sine of 0 is equal to 0. Cosine of 0 is equal to 1. E of 0 is equal to 1. We still have the 4 in front of it, 4 C2. Right, so simplify this, we have 1 equal to 4 C2 plus 4. So move the 4 over, we have 4 C2 equal to negative 3. So C2 is equal to negative 3 over 4. Right, combine those together and put in the general solution. So the solution will be y equal to, this is the equation, the general solution. We substitute in C1 is 3 cosine of 4t minus 3 over 4 sine of 4t plus 2 e to the 2t. Once again, I will zoom out. So, I said this type of problem are not difficult, it's just a bit tedious. Complementary solution, auxiliary equation. So that's like previous section. This section, we're going to guess the form of the particular solution and we solve for it. Once we have those two, general solution is complementary solution plus particular solution. And then if we have initial condition, we'll substitute in there at that step. Right. So, I apologize for the long section, but we did cover 2 sections today, and I think good amount of examples. As always, I hope you find this video helpful. Thank you for watching, and see you in another video in differential equations.